Oh, hi everyone, my name is Tutokoko, and in today's tutorial I want to do introduction to trigonometric ratios and identity, because we will be making some of these ratios and identity in our future problem under integration. Okay, let's get started. When we talk about trigonometric ratios, we have to first of all consider right angle triangle. So we consider a right angle triangle A, B, C, in which angle B is 90 degree. So let us name angle C as alpha, and let us name angle A as our what? Angle beta. Okay, now I'm going to consider angle alpha. So let us consider alpha. So if this is alpha, this side is going to be the opposite to this angle, and this side is going to be the adjacent, and this side is going to be the hypotenuse. So if this is angle C, this side can be called side C. We use small letter. This is angle A, this side will be what? Side A. And this is angle B, this side is going to be what? Angle B. So from above, we know that AB is equals to C, and that is our opposite side. BC is equals to A, and that is our adjacent side of the triangle, and AC is hypotenuse, and that is B, which is the hypotenuse side of the triangle. So what are the trigonometry ratios that we want to talk about? So the trig ratios that we want to talk about, they are just three in number. Number one, we'll find what we call the sine of an angle. A sine, so find sine alpha. And by definition, sine alpha is opposite side divided by hypotenuse side. This implies that the sine of this angle is going to be, what is the opposite side? That is C divided by hypotenuse, that is what? B. Okay, the second trigonometry ratio is called the cosine of an angle. That is cosine of alpha, and that is adjacent divided by hypotenuse. So cos alpha is equals to adjacent is A divided by B. That's A divided by B. And number three is the tangent of an angle of this same alpha, and that will give me opposite divided by adjacent. So the opposite side is C divided by, that's C divided by A. Okay, so we'll now find the inverse of trigonometry ratio. So we may be asked to find the inverse of all these trigonometry ratio, because we will still use it when we get to integration. Okay, so let's start. So that is number 4. The inverse of sine is written as sine inverse. The inverse of this angle is given as what? That is 1 divided by sine alpha, or say arc sine alpha is equals to, so the inverse means, inverse simply means B will move up and C will come down, and that's going to give us what? Hypotenuse divided by opposite. So it means that the inverse of that angle is equals to that's B divided by C. And the inverse of sine is called cosec. It's called what? Cosec. It's called cosec. So we can write this one as what? Cosec alpha. That is equals to B over what? C, which is equals to 1 divided by sine alpha. So note this trigonometry, inverse trigonometry ratio, very important. So that means wherever I see 1 divided by sine alpha, it means what? Cosec alpha. Okay, let's move on. Number 5, we find the inverse of what? Inverse of cosine of an angle. And the inverse of cosine of an angle is called sec. It's called what? Sec. So sec alpha is the inverse of this, and that is what? Hypotenuse divided by adjacent. So therefore, the secant of this angle is equals to, so B will go up and A will come down, and that's what? B divided by A, which is the same thing as 1 divided by what? Cos alpha. So it means sec alpha is equals to 1 divided by cos alpha, which is equals to B divided by A. Okay, you are doing well. And the last but not the least is called cotangent. The short form is what? Cot. So the cot of this angle is the same thing as what? The inverse of what? Tan of that same angle, which is equals to adjacent divided by opposite. So this implies that cot alpha is equals to 1 divided by tan alpha, which is now equals to, where is our tan? That is A divided by C. That is A divided by C. Alright, so these are the 6 basic trigonometry ratios that you know. There are 3 basic trigonometric ratios. Then the inverse of each of these ratios will give us cosec, sec, and cot respectively. So having known this, let's look at the next thing.